Hi everyone. Over the years, I've been asked to share my resistor, variable resistor, potentiometer, rheostat, whatever you want to call them, cleaning process. And it is a little bit more in depth than a normal cleaning process, and I'm about to share that little secret with you. Now, I've had many companies want to use me for advertising for their, cleaning supplies. And I'm always reluctant to do that because I'm not really sure how well they work until I use them for a while, and I don't want to lead anybody astray. Everything I share with you is tried, tested, and true, as is the process that I'm going to show you here. And it involves a bunch of different chemicals from different manufacturers, and it's kind of a blend of what works the best to lubricate and keep all of these things working correctly. And you'll come across some very odd little controls, high quality controls like these Allen Bradley ones right here. And I'll open this up and I'll show you what I mean in a little bit. And the lubrication inside of those things is a little bit more finicky. And of course, with devices like this, you can't get inside. They're completely sealed. So they have a shellac coating on the outside that has to be broken. And they are high quality, but they do get noisy. And what I'm going to do is also share some of my breakout boards. So that will be an attachment just below this video, and I'll talk about that here in just a bit. I've had many requests for breakout boards to take small surface mount components and allow you to plug them into a breadboard so you can experiment with them. So I use those all the time. So I'll get into that here in just a little bit. So what I'll do is I'll clear this off right here, and I'll grab one of these things and I'll start with one of them, and I'll go through the process of carbon track and wire wound and all that kind of stuff, and we'll clean some variable resistors together. Just before we get started cleaning these controls, I want you to know that if you're going to clean your controls with any of these chemicals, you're doing so at your own risk. A lot of the times you need to be very careful. You need to try these on some sort of a sacrificial control just to make sure that the chemicals will not harm the control. So again, if you're following along, you're doing so at your own risk. Follow the safety precautions on the can itself, and you should always wear gloves like what I'm doing. You don't want these chemicals on your hands because they're not good for you. And you want to make sure that if you're going to be doing this, you should be doing it in a well-ventilated area. A lot of us, like I'm going to be doing right here on the bench to show you, will try and do this stuff on the bench or have the radio chassis on the bench. Be careful, because a lot of times when you spray these things, you'll be spraying it into a control and it can splash on your face, and you have to be careful you don't get this stuff in your eyes. So wear adequate eye protection and protect your test gear as well. If you're going to do any of this kind of stuff on your bench, you want to make sure that when you spray it, you're not going to deflect this onto, say, the nice screen of your oscilloscope, or if you have any exposed paper around like speakers or any documentation, you want to get that out of the way, because once the oil gets on the documentation, it's on there for good. So lots of things to keep in mind. The best thing to do is to do this kind of stuff outdoors. I'm doing this on the bench just to show you this right now. Of course, all of us have at one point in time done this on the bench, like what I'm doing right now to show you this, because I have to have a camera here. And, of course, you've sprayed stuff into a control and you've gotten this all over something that you don't want to. Another thing is with the chemicals, after you spray the control, you'll notice that a lot of the times it'll pool inside the control. And then when you move the radio chassis, the pool will run out of the opening and then run down the inside of the chassis. And you don't want this stuff to get on any type of a cardboard IF coil form or oscillator coil forms, because getting any kind of moisture on a coil form will change the Q of the coil, and of course you're going to start to deal with IF band alignment issues, and you'll align your radio all up and it'll work perfectly. And if you're using a contact cleaner, that happens to evaporate after a while. After you've done your alignment, not realizing it, you'll come back 6 months later and wonder why your radio's alignment is in outer space. Well, it's because the coil forms have all dried up and they've kind of returned to where they used to be. Lots of things to keep in mind. I could keep going and going and going about the issues that, can arise from using contact cleaner in an open chassis and things like that. So those are some of the major ones. So now, here's the deal. I'm not sponsored at all by any of these companies. They have offered to sponsor me in the past a lot. And I haven't taken on any sponsorship because not only do I not want to, be advertising products on my normal YouTube channel other than what, the ads that Google places on them, but as I say, I want to be sure that what I'm showing you is correct. I want to make sure that the products are good. And one of the companies that has been after me for a long period of time is this company right here. So they've offered many times to advertise. They want to advertise, and then they offered all sorts of interesting things, shipping a whole lot of this stuff and all sorts of different types of compensation. So I've never taken that because I don't know at the time. I didn't know what this stuff was like. I've seen it in use. I've used it sporadically myself, but nothing over a long period of time. The one that I've been using forever and that works incredibly well, here's an open can here, so you can see it up here in Canada. It's pretty pricey, this stuff. So this is what it looks like when it's brand new. This is an unopened can. This is the MG Chemical Super Contact Cleaner. I really like this stuff. And the way you tell that you're getting the the right one is look at the color of the band. This is the one with the gold band. Different MG Chemical Contact Cleaners have different colored bands on them. In fact, what I'm going to do is just zoom on out here a little bit. So they have different colored bands, i.e., just let me roll back and grab different ones. So here's another one. And here's another one. And let's see if I got any more in here. They're all over the place. Oh, here's another one. And let's see. Anyways, I can keep going. You get the idea. Okay, so these here, I find they all work decently well. This is a very commonly known contact cleaner here. I find that I rarely use this stuff. So a lot of people used to be able to get this off the shelf at a lot of the stores. This one here is the one to go for. So if you need something that's going to, dry right up, this is the stuff here. And these two here, I find that I very rarely use it. These are very old cans. So this, if you need something, a lot of the older tuners, things like that, and televisions that you wanted a dry contact on or something like that, this would probably be the one that you would want to use. It works well. The problems with using this kind of stuff in any type of variable resistor is that it's zero residue and it dries up. And after you spray this kind of stuff in, a lot of the times it's going to wash out any type of lubrication in a control. So these two here are great for cleaning and for getting rid of that scratchy sound that all of us absolutely hate. Now, there's a lot of things that cause a scratchy sound in a potentiometer like this, and a lot of it is applied DC across it. So if you have a capacitor, whether it's electrolytic in a newer type of, say, amplifier, radio receiver, or whether it's in an older type of equipment and it has a capacitor, say paper or foil or something in line with this, what happens is when they put DC across this variable resistor, if there's any DC on a lot of these things, it makes them extremely scratchy sounding. So there's a troubleshooting tip for you right there. If you're dealing with an old amplifier and you're moving the volume and bass and treble controls and they're really scratchy and you can't really seem to get rid of it and you're thinking that replacing a control is going to stop that, a lot of the time it's a leaky cap putting DC across it. And of course, any type of DC across this, especially if one end of this is running to ground or if a wiper is or something like that, you're going to get that gravelly sound when you move this. So leaky caps are one of the things that will lead people astray to thinking that your variable resistor is actually noisy when it's not. So keep that in mind. So wasn't expecting to bring that up, but this is something that should get mentioned. So now, using this stuff in here is actually a really simple process. You can see that this one here is sacrificial because I haven't treated this one too incredibly well. It's nice and smooth. It's unfortunate, but this one here was in a bad experiment, an experiment that let the smoke out of this thing. At any rate, so this can very easily be sprayed into here. You can see that there's an opening in here, whereas if we take a look at, say, an Allen Bradley control, that's this one here, there is no opening at all. This thing is completely sealed, and they have a shellac seal on them. And we'll talk about this one here in a little bit. So this one here is very easy. Now, you'll find, as I mentioned before, inside the chassis, that these things are, when you're working on something, usually the chassis is on its side or, face down or whatever, you can spray it in there, you can get quite a pool in there. And the whole thing that you want to do is once you spray it in there, you just don't want to do this and end it. You got to do this for a long period of time, and you want to hit the stops. So what I do is I'll come over to the stop and I'll tap the stop a whole bunch of times, and then I'll go over to the other end and then I'll tap the stop a whole bunch of times, and I mean a lot. I'm just doing this short here. And then I'll run through the entire thing a whole bunch of times. After that's done, I'll do it again. So I'll spray this in here again, and I will do this again from end to end. And you need to really work this in. So what I'll do is I'll spray some in here and I'll give you an idea. So this stuff really pools bad. So I'm going to cover this up so I don't get this all over everything, because this comes out of here pretty, pretty hard. So you can see now, you get that inside there, and you just want to move it around like so. And move it a lot. So I'm not gonna do this a whole bunch of times. Now, when you're doing this, you know that you'll feel a lot of these VRs, they have a really smooth feel to them, and that's because there's a nice little layer of grease inside here that you're gonna nicely wash out with this stuff. Okay, so you want to keep moving this, and it's going to get smoother and smoother, and it'll move quicker and quicker and quicker until it's really free. Like, it's really easing up now because that grease is starting to take this stuff. And then what you want to do is, after you've done it once, you want to do this again, like so. And you really want to work this stuff in here. You want to get all the dust and debris. Now, one of the things that I suggest whenever you're designing something with a variable resistor or control like this is you want to mount these things down in the chassis. So if the chassis is sitting up, say you're looking at the top side of the chassis, if you have the chance, you can remove the tang in a lot of these things, and you can see the shaft isn't indexed so that you can tighten the screw on the knob anywhere you want. Now you'll see this pour out of here. See how that's going to come out of there? That's actually not too bad. I think it all ran out as I was turning this. That's one of the other issues. When you're designing something, like, probably came all out of this little hole here. So when you're mounting something like this in a chassis, you want to mount them like this because dust settles on the top. A lot of manufacturers that aren't too incredibly swift, what they do is they, mount them up like this inside of a piece of equipment, and they'll have an air grate on the top, or, a vent hole or some sort on the top. And then the dust settles in and it gets inside these things, and then they become horribly noisy. So if you have the chance, if you're working on something and you really want the thing to last, remove the index. A lot of the time you can even bend them. So I just take a pair of trimmers and bend the index. Again, this is if the shaft isn't indexed. You just grab this with your trimmer. They're pretty soft, and a lot of the times they'll just break off. But move them off to the side, and then turn the control around and remount it so that it's face down. In some cases where, it's going to be in a very dirty environment, if this here is just the stop. So when you turn this, it hits the stop, so you can't keep rotating it, and that's what this is here. So what you want to do is you want to make sure that you put a piece of tape or something over that so no dust can get in there as well. As long as this sits down, this will keep your controls, quiet for a very long period of time. Like, these Allen Bradley controls are designed to be in a rough environment, and they're completely sealed up. So these here, they last a very long time, but they do tend to get very noisy, and that's because this is a really high quality control, and I'll show you what I mean here in just a moment. So now, once you've worked on this thing for a long period of time, say you've moved this back and forth for about 5 minutes or so, maybe even longer, and then hose it out a few times. So you want to hose that out. Of course, it's going to leak out of this little hole back here. So, and it comes out of the bottom too. You'll find that, again, if this is in a chassis and you're spraying this in a chassis, you won't notice it, but it seems to always happen like this. It'll go into a corner and run down the corner, right down to the bottom end of the chassis. You'll have a little pool in the bottom, and you're like, how did that go down there? And you'll see just a very small, thin path, and it just follows all the way down to the bottom of the chassis, and it'll sit there. So you want to make sure that you soak all this stuff up, and of course, taking note of the, this stuff. A lot of this stuff is extremely flammable, so you need to be very careful with this. I notice with a lot of these things too that you can see this, they don't seal very well. After you spray this, it gathers under here. So if you move your can around, I've had this with many of these cans, if you move these cans around and you tip them, you're going to see that you're going to get a pool out of here a lot of the time. I've had many cans that do that. I don't know if it's a defect in these cans or in this sprayer, but with this particular one, it does that. So now this also works very, very well. Same kind of idea. You can set the pressure level on this. So you can see it says low, medium, and high. So you can set the flow rate of how much you want to come out of this thing. So usually I have it on low because you usually don't need anything more than low. And just give it a nice little hose down inside there. And as you can see, even on low, tons of it comes out. And you can use that. Now this stuff here I've been using for, I can't tell you how long. This stuff I've been using for probably 25, 30 years. And it works incredibly well. This stuff here, it is very good. This stuff here I started using only a few years back. And it works very well too. I would say that these two are on par with each other. Very, very close. So they're just, yeah, these are the two best ones. And as I say, you can pretty much almost ignore all the other types. And again, no sponsorship. I'm just telling you what I know. Okay. So now you're going to find out that in most of the times, if you spray this deoxit stuff in here, you'll find that after a while, it will completely dry up. Now, I found that many times. I'll spray this in a control and leave it alone and come back and it's bone dry. It seems so it cleans it out really good. But now what's happening? Well, it's obviously getting rid of all the lubrication in there. And now whenever you're moving this thing, you're going to put a massive amount of wear on this. Right? You can hear it, right? So you can hear that, you know, but just by moving this thing up and down, you're going to put a lot of wear on that. And of course, we're going to definitely want to stop that from happening. Now, this is, again, more personal experience. If you use this, any type of these chemicals, you're doing so at your own risk. I've experimented with lots of different types of lubricants in VRs, and I've been doing this for a very long period of time. And the best thing I found that works, this is part of the secret here, is this stuff. This stuff is incredible, and it works incredible in VRs. That old Westinghouse radio that I fixed had horribly noisy VRs. So incredibly staticky VRs. In fact, you know, if you were to remove the stop and put a motor on the shaft, you could use those things as a static generator. It would just be a continual noise. So I sprayed the deoxin in it first and let it sit for a long period of time. Again, that's that big Westinghouse that you now see in the corner of Lab 2. I let it sit inside for a very long period of time and moved it around. And just for the, you know, the sake of pure experimentation, I let it sit for a couple of days and it became noisy again because it dries right up. So what it is, I take some of this stuff and give it a shot inside there, move it around. Everything gets nice and smooth. And to this day, it's dead silent. That control is dead silent and smooth. Now, the nice thing about this stuff here is it comes out like a foam. And so if you're going to be spraying this into an opening, what happens is that foam goes into the opening and it expands in there and it hits all the components. And then if you move it around, you can spread the foam around and then it slowly turns into this oil that stays, and it'll stay on the track and it'll get into the shaft area, and it makes for a very, very smooth operation. Now, again, the controls that I'm using this on are, you know, these older controls like this, and I have some newer controls that works well on. You have to be careful with any type of a chemical that you're going to be using on some of the newer stuff because a lot of them are plastic. They have plastic controls in them. So you want to take care, you know, if you have the ability to have a sacrificial control, experiment with it for a while. Spray some of the stuff in and move it around, let it sit for a while and come back a week later or something like that and, you know, see how it is. Is it staticky? And do your own experimentation. I found most of the time that this stuff here has zero effect on any control. Now, this is my own research, and as I say, if you're following along, you're doing so at your own risk. There are a lot of variables here, and this is why I'm repeating this, right? So now, this is a rattle can, and you need to shake this up. You can hear that. I don't know if you can hear that. Okay, so you got to get that thing rattling in there, and you want to shake it up really good. So usually what I do is I hold this in my hand, and I shake it like this really quick. You can hear that? And that's just me doing this really, really quick. Now, you'll notice that whenever you're doing this with paint as well, the rattle ball is in the bottom, and a lot of the time it gets stuck. So I'll hold the can down at first, and I'll shake it like this violently at the bottom to get that ball just moving in the bottom portion. And then after that, then I'll do this really fast. And this is what I'm doing really fast. And you can hear it rattles in there very well. And that really moves the paint around. In this case, it'll be moving the oil around in here. So now these things come with a straw, and you want to be careful when you put the straw on. Always angle the straw away from yourself. And again, appropriate eye protection. So you want to angle the straw away from yourself so that it doesn't spray you. Never look at this, or even on the contact cleaners, never look at this. And when you're poking this in here, cover it up to make sure that you're not going to be hosing yourself down with this. And sometimes they're a little bit tough to get in, but you want it like that so that they stay in there. Okay, and you'll notice in the can at the top, there's a little indent here. That's to snap the straw in when you're done. A lot of people don't know that. So a lot of the times they're taped to the side. So you can see a little tape here that it comes in. And when you're done, you just clip it into the lid. So basically you take the straw off and then just press it into the lid. And it's good for next time. So I'll spray some of this on the mat here and give you an idea of what this stuff looks like when it comes out, okay? It looks like that. All right, and as you can see, it kind of slowly just turns into a light oil, right? You can see it just turns into a light oil like that. So now what you want to do is just give it a shot. So cover it up like so. Give it a shot, and you can remove the excess. Right? You got to remember this stuff foams up, so it really looks like there's a huge amount in there, but there really isn't. And then rotate the control like this, and that right now, I can tell you, is as smooth as glass. So already. Now, if you have the control out, it's always a good idea to run it down like so, so that way the oil will run down into here and get back onto the actual shaft of the VR. And of course, just move it around a whole lot. And then it'll prevent this from drying out. You want to make sure that you wipe the control down, clean everything off. And the stuff works very, very well. Now, again, you don't want to be using this where there's going to be a lot of current across a device like something like this. You never spray any kind of an oil onto this track because there is a brush here, and these are designed to control current. So a lot of the times there is sparking on the track. This is nichrome wire, so it's very resilient. The only place that you're going to want to lubricate something like this is in the shaft itself. So a lot of the times there's a little retainer clip that you can remove, and you can take the whole unit apart. Many times you'll have to sand this to get this out because this will be marred by a screw that's been tightened down onto the shaft, because a lot of times these are in an industrial setting. You see the screw here is on the index. A lot of the times it'll run over to the side here and it'll stop this from coming apart. So sometimes you'll have to run a file across this a little bit, press this out, clean it all out, and then spray a bit of this lubricant on it right here, and press this back in and dry the track off. Again, you really don't want to be using this kind of stuff anywhere where there's any type of a current across the device, because this is an oil, and of course, oils can be flammable if something ever goes wrong. So you want to be very careful, and I can tell you that right now, it just feels so incredibly nice. For a bad potentiometer, it sure feels like it wants to work again. So anyways, just as smooth as glass now. And this stuff here works great. It takes the static away and keeps it away in many applications. Here's an Allen Bradley control out of an older Tektronix oscilloscope. So what ended up happening is I browsed the auction sites for parts, and somebody had taken a bunch of 500 series scopes apart, and stripped them right down to nothing, bent the faces and everything. But he had the rest of the components for sale, tube sockets, chassis, standoffs, things like that, so I promptly went to go and get them. That's how I ended up with these. No, I have not destroyed any 500 series scopes. To me, that's horrible. When I saw that, it's kind of the look of horror in my face when I saw these, dismantled scopes, beautiful looking scopes too, and just destroyed for their parts. At any rate, so they have really nice controls in them. Of course, Tektronix only used the highest quality stuff. This is Allen Bradley, as you see here. Very, very high quality control. And these get very noisy. Even though they're high quality, they get really noisy, and here's why. So in order to get into something like this, it's really quite simple. You can get a pair of clippers like this, and you put the blade up against the area that will separate from the chassis, or from the face of this thing. And then what you want to do is just pry up like so. So you'll see one here, and one here like so. And that's how you get inside these things. It's really quite simple. Sometimes you have to break the shellac. Sometimes they come off relatively easy, I guess, just depending on how long they've been in service. This one here comes apart that easy. Now, when I say high quality control, you can see what I mean by high quality in here. You can see that it has a carbon track. Let's see, get that on there. You can see in there's a carbon track right in the material. And if that's not good enough, the wiper has a carbon brush. That's how good these things are. And that one has a lot of life left in it yet, but it is noisy. And the reason it has a lot of life in it is because this came, I believe, if I remember correctly, out of the voltage reference area. So it's basically set it and forget it type of control. So it's really not moving around all that much. So cleaning these things out is the same procedure as before. You want to take your preferred contact cleaner, and what you're going to do is just give it a shot. And then with something like this, you're going to need a screwdriver, which I have right over here. And you're just going to want to move this back and forth. Now listen, can you hear that? That's not something that you want to be listening to. But at any rate, you want to clean it out. Now, when you remove the back portion of this thing, let's get this back down here like so. When you remove the back portion of this thing, the stop is gone. So what you want to do before you put the back on is put the wiper off to one side. Don't leave the, this down here like so in that open area. You want to have it off to one side. So put it at either 3 or 9 o'clock and then put the back on and you should be okay. So you can hear this one here is horribly noisy. So you want to move this around a whole lot, right? And then hose it out one more time to get any of the grit off of there, right? Because if there's any crap in there, any carbon or whatever, you want to dry this out. So let this dry up. This contact cleaner stuff will end up drying up inside of here. Sometimes just a slight residue left over. And then the same kind of deal with this. Give it just a quick shot of this. So I'm going to do this while it's wet because it's still wet. Just, that's it. It's one quick shot. And move this around. And I'll turn it right. Hear that? That's my glove. Smooth as glass. Dry off the excess here on the sides. Don't using any type of a cloth that will put lint in here. Be very careful about that. It's like working on a transmission. If you're ever working on an automotive transmission, you cannot towel dry or cloth dry any of the components in that transmission. Clutch packs, plates, pistons, seals, you cannot dry any of it with a towel. It has to be dried with compressed air. In this case, what you want to do is you want to use a lint-free cloth. Just go around the edge. Go around the edge to get no lint in here whatsoever. It's another really good reason to wear gloves. And then when you're done, you can just put the cap back on. So this one here is that's fine as long as it's not in the area of the stop. You can put this back on, and then when you're done, all you do is you take a pair of pliers and then you pinch right here. So you pinch here. I'll see if I have a pair in here that's going to do it. I have my big old rusty, ugly pair sitting here. So this will work for now. Just open them up and give this a pinch right here like so, okay? So move this in one. Just like so. You see how that's folding in? So you want to do that. You want to be very careful with these because what ends up happening is that if you push too hard on this, you can sometimes chip this. So you want to go in there like so, and you want to go all the way around and pinch these all back together nice and tight. So you can see, I can hit both of these probably close to the same time here. So that one will go back in there like so. And when you're done, what you want to do is pinch this tight like so. Pinch it onto the top. So I got to watch what I'm doing here. I'm watching myself in a viewfinder and that's not going too incredibly well. So I'll move that right there so I'm not hitting anything. Got to make sure that you're not hitting the stop. You can see the stop is folded over because this was on an L bracket. So I'll go in there like so, and like so, and you can see how that one is all tightened up now. Just like so, back on there again. And you do that with all of them. Sometimes if you want, what you can do is you can very carefully take a screwdriver like so, just to get that extra, just a little bit of tightness, put this on here, and then tap a screwdriver with a hammer very lightly, and that pushes this in the rest of the way, because there's a bit of a spring action happening here that doesn't allow it to perfectly go down, as you can see right there. So if you tap this, it'll bring it right in and make it nice and tight. So that's something that you want to keep in mind with these particular types of controls. And this here now will be as smooth as glass. And oh yeah, that's very nice. And this will last a very long time. Again, keeping in mind that if you're going to be doing this on any type of control that has current across it, you got to be careful. All right, so it's any type of sparking or anything like that, you want to be very, very careful. Again, this is really just turns into a somewhat of not really a light oil, but an oil that sticks to the surface, so it stays where you put it. And that's very important. A lot of the times, if you use just a normal type of oil, like a 3-in-1 or something like that, it almost destroys these things. So I don't know what the formulation is in that stuff, but it's just not a good idea to put that in here. So this stuff here seems to really do the trick, and it doesn't damage the control. If you're going to be working on something like this, as you can see, again, this is wire wound. So you only want to be doing any type of lubrication in the shaft area. Usually wire wound controls are used for controlling some form of current. So you'll find these things in transmitters controlling the filament voltage, so they'll be on the primary side of a filament transformer. Or you'll find these things controlling current on the grid, say on the screen grid of a 5763 in a Johnson Viking Valiant, the drive control on the front. So you'll find that they're controlling quite a bit of current, and there's a lot of current across it as well because they get really hot. They're using 5-watt variable resistors in there. You don't want to be getting any type of an oil on the track in a case like that, obviously, because oil burns, and well, we know what happens, right? So you got to be careful with that kind of stuff. Again, nichrome wire. Now, in some chassis, you'll find that these are very hard to get into. This will be completely sealed. There's just no opening in these things at all, kind of like these things. And you're thinking to yourself, okay, I've got 6 hours of teardown time pulling the circuit board out or pulling these all out and getting inside them. Is there any way that I can get into these things in an easier way? And a lot of the times, no. But in some cases, you can take a pin vise. Now, for those of you that don't know what a pin vise is, this is a pin vise. That's what it's called. You can put a small drill bit in it, and as you can see, you can brace this in your hand like so, and you can drill with it. This thing here will slip in your hand. It's nice and smooth, and you can drill holes with it. So if you know what's inside the variable resistor or potentiometer, a lot of the times you can go in an area that you can access, and you can very carefully work away at it and put a small hole in the case. Now, a lot of the times I do this with a magnet right on the outside so that no steel shavings fall in. You got to be careful, right? Because when you push through this, it's going to push some steel shavings in there. You don't want any of them to fall inside, because if steel gets in there, it's going to really destroy things. So that is in a worst case scenario. You can actually put a small hole in these. Now, if you don't know what's underneath, you wouldn't want to be drilling this, because immediately if I drilled a hole into this, what would happen? I'd go right into the nichrome wire, and I would render this thing useless. It would completely destroy it. Whereas in a case like this, there's just a carbon track down here, and then there's a wiper here and a brush. So if you were very, very careful and had this thing not sitting at the stop, you could very carefully put a small hole in there and give it a blast of cleaner, let it dry up for a while, put it in a hot area, and then just give it a shot of lubricant in there, and away you go. And that is in an absolute worst case scenario. Now, when I say worst case scenario, I absolutely mean that. If you can spend the 6 hours, and sometimes it takes that, to take these units apart and take every variable resistor apart and clean it, that's the best way to do it. You can really wash them out well. And after you've used the actual cleaner on them, you can air dry them with compressed air. So dry them up really good inside to get all of this stuff off of them. And then, of course, you can't leave them dry. You don't want to ever you heard what this one sounded like, even with just the cleaner on it, squeaking and everything. You don't want to leave them dry. You definitely want them lubricated, and you want to make sure that there is a fair amount of lubrication in there, so that way the device lasts a very long time. Again, no current across them. You got to be very careful with this. Remember that you are putting an oil inside here, and this is a completely sealed unit at this time. So you want to be very careful with that. There are all sorts of other little types of controls. This one here, same kind of idea. You can spray it in the gap, and then work it around, and then give it just a touch of lubricant in there, and they'll last a very long time. This is the stop here for this one here. So it hits the stop. Things that you want to be leery about with these ones here that have rivets. Don't move these things excessively, because if that rivet gets loose, that's the contact to the carbon track on the bottom side. Do not solder up in this area unless it's absolutely necessary, because if you get flux under there, you'll get an intermittent control. You want to keep the solder right at the ends of these things as much as possible. You'll notice this with a lot of these other older controls. They even have a relief. You can see how it runs through the disc. All right, so it runs through the fiber disc and up onto the top as a strain relief. And then inside it makes the connection. You don't want to be moving these things around too much. A lot of the times you'll break connections. Older, well, this really isn't all that old, but units like this, you can see that these ones here already move. And that will pose a problem in the future. So if you found that you've made one of these things move, what you want to do is spray contact cleaner under there and bend this straight. Get a pair of pliers that will get into there. I'll just use this as an example, but get a pair of pliers that get into there and give it a good squeeze. You want to make sure that that rivet is tight. If not, you're going to have an intermittent control. And if it's on the ground end and it ever comes up, a lot of the times you'll get some very loud music in an audio amplifier or something like that if the ground end comes up. So always keep that in mind. Try and keep the soldering in this area down to an absolute minimum, and try and keep the movement down to a minimum as well, or you'll get a faulty control. You'll see controls like this in a lot of high voltage applications. This is a spacer here because this is sitting at a high potential. This is either going to be a focus control or it's going to be an intensity control for an oscilloscope. And same kind of thing goes with this. You can get the cleaner into the actual stop areas and the reliefs, things like that. You can get them in there. Be careful with stuff like this because, you know, you don't want to create any issues. There's high voltage across this. The reason it has this insulator is to insulate this, keep this far away from the chassis. So if you're ever working on anything that has this, know that the potentiometer variable resistor behind it is going to most likely be hot. So you got to be very, very careful. This is on the chassis like so, and you can see it stood off quite a ways to keep the high voltage isolation away. So just something else to keep in mind when you're working on something like this. Be very, very careful. Staggered controls, we have an on-off switch and a dual control here. So you see we have one variable potentiometer here, and then we have another one here, and this one will be in the on-off. So the one that's in the center goes to the back, the one on the outside goes to the larger unit here. Same kind of idea. You'll see that this one here, there's pretty much no entry. So this would have to be pried apart and taken apart. You'll have to take off the retainer on the shaft and then take this whole thing apart. These are a little bit difficult to get inside of. This one here, so you want to, the bottom one is relatively easy. This is just a little opening that doesn't go inside. That's just sitting there like that. So you'd have to get, pry these tabs up and pull this apart and get inside there and clean it out whenever you see stagger. This is common for older televisions and things like that. So not so common for older radios. Really long shaft to usually go through the front of the TV. So see, what else do I have here? Another one here. This one here is interesting. This one here has a hollow shaft. So obviously been used for something else or something that came out of the center of it. Same kind of idea. You can get into the internals in here by spraying in the opening. Things like that. So if you're lucky enough to come across an amplifier where the controls are like this and you're looking down at it like this, that's nice. When you're done with it and you've cleaned them all out, you'll wish they were like this, because if for some reason it was a customer of yours, he's going to be coming back and are, probably growling at you in a short period because, again, the dust is going to settle in there. So anytime that you have the option of taking a control like this and turning it down so that the dust can't settle inside, do yourself the favor. And where did that monster VR go that I had? Way out of the way. It's so big that it hides. Actually, it was on the other side of lab 1 here. So something like this, again, designed to control a ton of current. This thing here is, nice big brush here. You don't want to be putting anything on here. This is nichrome wire, and you want that to rub dry. Again, brush, nichrome wire, it's a very hard surface, and this has got a nice polish to it. So you definitely want to, keep that dry. The only place that you're going to want to be lubricating anything on this would be the actual shaft area. It's a big spring here, holding everything into place. Nice big control. Turning this thing feels like an old gravelly bearing, but that's the way they are. So that's the way these old ones are, and they'll last a long period of time. If you knew that this thing was in some form of a low current application, you could probably put something on the track. But again, it's, this is designed to be absolutely dry, because most of the time when you're doing this is something that would be used in controlling the primary of a heater transformer in a large transmitter. So this would be bolted up to the wall of the transmitter, and the primary of the filament transformer would be, this would be in series with that. And then you could vary the filament voltage on the transmitting tubes. The Gates has a small one of these in it. So this would be used in one of the higher power 10 kilowatt jobs, something like that. At any rate, that's cleaning VRs and how to do it, and things to do and things not to do. So be very careful with this information and use common sense when you're doing this stuff. Again, plastic controls you want to be very careful around. Oh, one other thing I should mention, and I've had this question quite often. You get seized controls. A lot of the times you get seized band switches and you can't turn these things. You get a knob with three different set screws on it, and you can't turn it. It's almost twisting the shaft off. Well, what you do is this, okay? And you have to, again, use this at your own kind of discretion. So you can take a soldering iron like this. This is my old Weller. And what you do is you make your own tips for this. I've talked about this. You make your own tips for these old irons here. So I'll grab a piece of copper. Let's see. So this hasn't been stripped yet. Okay, so this would be stripped and this would be bare copper. So what you do is you make your own tip, and you go like this with the tip. Okay, so keep in mind, again, this is bare. All right, so this is bare. There is no shielding on this at the time. And then what you would do is you would heat that up. And what you can do, again, is you put a little bit of penetrating oil, let it sit overnight. Liquid wrench works very good for this. Let it sit overnight, and then when you're using this, you have to be careful, because this will get so hot that it will ignite whatever you put on there, okay? But you can heat this shaft up very well with this, and once you heat it, because you're heating the outside expands and it'll break free from the inside shaft, and then you can work it and move it free. And then once you get some penetrating oil, or like liquid wrench or whatever, inside there, and you start moving it and you break it free, away you go. So that's a trick that works extremely well. So again, of course, this is going to be stripped, so just give you an idea of what's going on here. I can get this off. I can't do this on camera here because I'm reaching. So there we go. So this again would be stripped, right? And you'd be using the bare copper in there, and the whole thing would be like that. And you just put the bare copper around there and in there, and then very carefully, give the thing some heat. You don't want to, again, you got to be careful, because if there's any type of lubricant or any type of liquid wrench or anything like that on here, and you keep this on here, it is going to ignite. So you got to be very careful, because this gets really hot. It's a soldering iron, right? So, a few turns of this around here, just like so, right? And then you make your own tip, put it into here and tighten it down, a couple of shots, and get this nice and hot. Again, using common sense, and then you'll be able to break this free. Again, you're doing this at your own risk. Be careful. Done it many times. Works incredibly well. So I don't know what it is with old National receivers. I know their tolerances are very tight, but so many band switches and VRs that just seize right up on those things. I've got lots of National receivers here to do. So I have let's move this out of the way here. I have an entire pile of National receivers. So at any rate, lots of really neat looking old receivers to do. And their neat little carriage system in the bottom that moves along in all the contacts. So kind of neat. So there you have it. I hope that helps you out with cleaning your variable resistors and getting them moving again and making them last an incredibly long time. I've had incredible success with what I've shown you here, and I've never displayed this ever. This is the first time. Again, I don't like to display things like this because, there's so many different types of chemicals out there, but I'm pretty comfortable with the ones that I've found for myself, and it's something nice to share with all of you, because I know how frustrating it can be when you have a noisy control or something like that. It's just, and you can't find a replacement. And a lot of this older equipment, these controls are, they're unobtainium, completely unobtainium. So it's nice to bring them back to life again. And this stuff, and this stuff, and this stuff works miracles. Below this video is an attachment for some breakout boards, so you can take surface mount components and plug them into your breadboard to do experimentation. Very, very handy things to have. I use these things all the time. As you can see, I've been whittling away at this one. It's actually quite a bit bigger. The attachment that you have below this video has a lot more components on it. It's just that, again, I've been cutting pieces off as I've been needing them. Now, I cut these off with a bandsaw or a shear. If you're going to use a bandsaw, use the appropriate safety precautions. Same thing with a shear. So I'll show you. This is just standard FR4 board. All you do is you just put your shear wherever on the line there, whichever one you want to cut off, and go like this. They don't have to be pretty. You're just cutting them off so that you can plug something into your breadboard. Now, if you wanted to solder some single inline pins to the bottom here, what you do is you cut it very close to the pads, just like so. And that will allow you to take some single inline pins just like this and solder them directly to the pads. And you can have your component on here and plug it into your breadboard like this, and away you go. Very, very handy to have, especially if you have some really neat surface mount components that you want to try out in a, in a setting where you can do some experimentation. And of course, the breadboard is the ultimate place to do that. So these will be below as well. This is a part of the board. I've already cut these off a long time ago. These are optos, I believe. And these are single inline pins. You just cut them to size and you can insert them through. If you're going to use just single components like this, I strongly suggest that you solder them like this, because they take up a lot less room on the board. You can plug these in. These you really don't have a choice, so you have to plug them in like so, and you'll have a few slots each side available. And if you're really tricky, you can go underneath and go into the ones that are remaining, just like so. Very, very handy to have, especially if you're, say, converting something from dip to surface mount. So you want to compact your project, and say you have for example, a TL494 that's a dip, and you want to go to a surface mount, and you want to verify that the surface mount will perform the same as the dip. This is very important because dip and surface mount components often act different. So you would put that on here and plug it in and verify it and make sure that it's okay in your new design. This is the stuff that I do in all of my designs. I verify all of these components before I do this. So if I design something on a breadboard, I will verify the surface mount components by putting it onto breakouts and plugging them in, just because often, not a lot, but often you'll find that a surface mount component will act just a little bit different than its dip counterpart. So something to keep in mind whenever you're building something, you always want to test the final device as the final device. You don't want to just design something with a dip and go, oh, okay, I'll choose a surface mount component and that'll be it. In some cases it'll work fine, in other cases it won't. And if you're dealing with RF and things like that, that is a completely different world, because size matters when you're dealing with RF. So very easy to use these things. Now I have lots and lots and lots of pad layouts for different and odd components. If you see me release a project and you go, hey, that would be a really neat layout to have so I could do some experimentation on a board, let me know and I will write it down and add it into the next release of breakout boards. I've got tube sockets, 9-pin, 7-pin octal tube sockets on little PC board breakouts, all sorts of interesting things like that. Relays, just odd components that that I had to design my own pad layouts because I haven't even found the layouts for the components. Things like that. So this is below, again, much bigger, and it's mirrored and everything like that. So again, toner transfer method, things like that. I've left the holes in the pad, so if you want to run wires or do something like that, you can do that. And if not, you can just, put the single inline pin right up to the breakout board and solder it right onto the little pads like that. So I hope that's helpful for you. And I've had many requests for these, so there you have it. Hope you enjoyed the video and you found this beneficial. If you're enjoying the videos, you can let me know by tapping the heart symbol just below this video here on Patreon. And I will talk to all of you very, very soon. Capacitor tester's coming along very, very well. And that's the reason I haven't had any YouTube videos launched lately, is because that's been all time consuming. So that's coming along. So that will be coming up very, very shortly. Hope you enjoyed. Bye for now.